5, 4, 3. Initialize fail lab.
My name is Dilworth. I'm a PhD candidate in molecular neuroscience at the California Institute of Technology. Today in the Fail Lab, we have Dr. Clifford Johnson, a professor of physics and astronomy at the University of Southern California. In 2005, Clifford won the Maxwell Medal from the Institute of Physics.
Electricity. It's one of the most important phenomena in our everyday lives. It works because inside conductors, like metals, there are lots of charged particles freely moving around. You can get them to move all in one direction to form electricity by connecting to a power source. Actually, the human body is an excellent conductor of electricity.
The body uses electricity on a small scale all the time. Neurons manipulate ions to transmit electrical charge. These charges encode signals that travel between brain regions or to specialized cells like muscles throughout our body.
Let's see what happens when the human body meets electricity.
Oh, John, now you come in. Yeah, John, now we're all gonna do it. Take your shoes off.
Come on, do it. Yeah, take your shoes off.
John, in the end, is taking his shoes off. He now has no insulator.
So here we have our science students. They've cleverly demonstrated their understanding of electricity by insulating themselves from the ground. The electrons want to flow from the source, the electric fence, to the ground. That's the pathway for them to conduct electricity. The boxes stop that until one of the students jumps off the box.
And current flows through them, as if they were a piece of metal.
It sounds like 100,000 volts would be much more dangerous than, say, 100 volts. But the thing you should care about is the current. The current is actually all about how many of those electrons are flowing, and that's measured in what's called milliamps.
The body has different physiological responses, depending on the amount of current and whether or not you're male or female. At around 5 milliamps, you get a slight shock, but it feels more like a tingle. Above that, the body starts to experience pain. At 20 milliamps, the nervous system becomes overloaded, and you start to experience involuntary muscle contractions. At around 50 milliamps, pain is extreme, and things like breathing and other functions become difficult. And above 100 milliamps, you get extreme burns, your heart fibrillates, and death is probable. But our Homo Sapiens didn't let that happen. So is this really a fail?
Well, the science that they demonstrated was good, and the fence was only designed to keep sheep in, so I would say it was a win for curiosity.
Playing with electricity is always dangerous. One undiagnosed heart condition and this would have been a massive fail. We want to know what you think. Was this a win or a fail? Also, send us clips of cool science experiments to analyze in the Fail Lab. And like us on Facebook where the conversation continues. Thank you so much, Clifford.
It was a pleasure.
And thanks to all of you for stopping by. We'll be back next week with another clip and more science. But until then, when you're hanging out with your friends and your curiosity leads to some shocking results, you've got zoochosis.